So here's another example. It's very similar to the last one. Find a pair of parametric equations that models the graph of, and they give us this. We know it's an upside down parabola, right? Using the parameter, and then x of t equals t again. Okay, so we'll just set up a table. We'll have a value for t. We'll have x of t, and then we'll have y of t. Now over here, because x of t is equal to t, we can replace then our x in our y equation to be 1 minus t squared. Okay, so we can put in things like, how big do I want to go? Maybe just -2, -1, 0, 1, and 2. Now, if you're wondering about those negative values of time, we're kind of ignoring that for right now because we talked about t representing time. But for now, we're just trying to get a picture of what's going on. Okay, so that means x of t is going to equal t. So that's not going to change. And then we're going to plug in the values. So you get -3 here, you get 0, you get 1, and 0, and -3. Whoops. I feel like I left something out. Okay, maybe not. All right, so now if we were to graph those, and we're graphing this based on x and y. Remember, t and x were being the same thing, though. X of t was t. Okay, so -2, -3, sorry. -2, -1, 2, 3, there we go. And then -1, 0, and then 0, 1, and so on. We were expecting a parabola. And then it curves like that, but it has to do with how is time progressing. So the curve is going up over time as time increases, up to 0. When time is 0, then it starts to decrease. Okay? Now you don't have to put those arrows necessarily unless they ask for that, but it's to show you why we're doing this. Okay? So as we get into a more complicated example, a little bit more complicated, in the next one, you'll be able to see it a little bit better.